Hello, Assalamualaikum. My name is Nurul Auni binti Ahmad Mukir and my group mate name is Muhammad Alif bin Muhammad Zafan. Today we want to present about our mini project for subject Design for Manufacturing and Assembly, DFMA. This is the presentation outline we will go through in this presentation. I will start with introduction. This is the picture of our product, which is mechanical pencil. Mechanical pencil, sometimes known as clutch pencil, is a pencil with a lid which is a removable and mechanically extensible solid pigment core. This mechanical pencil has 10 main components which are cap, body, grip, cone, pin, shaft, lid sleeve, gasket, eraser, and bush. This is the bill of material of the product. The cap is using material of plastic. The material of body is plastic also, and cap and body, the manufacturing of cap and body is plastic injection molding. And the grip material is rubber, and the manufacturing process is molding. The cone material is plastic, and the manufacturing process is plastic injection molding also. The pin material is steel, and the manufacturing process is machining. The shaft material is plastic, and the manufacturing process is plastic injection molding. The lid sleeve material is plastic, and also the manufacturing process is plastic injection molding. The gasket material is rubber, and the manufacturing process is molding. And eraser, also the material is rubber, and the manufacturing process is same with gasket, is molding. The bush material is plastic, and the manufacturing process is plastic injection molding. The figure at the right side shows that the 3D drawing of existing product of mechanical pencil before improvement. This is the DFA table. The table is used to analyze total operation time. All the data is used to find the assembly cost and also design efficiency of the product. The product part have 10 product, and the 10 part, and the total minimum part count is 1, and the manual handling time total is 20.72. The total of manual insertion time is 45 seconds. The total operation time is 65.72, and the assembly cost total is 45.31. And the result for design efficiency is 4.56%, and the assembly cost total is 0.37 cents. The recommendation of improvement. The lid sleeve and cone are where the improvement part has been made by combining the two part of it. They are not TMPC part, although they are made of the same material. In order to put in the lid sleeve properly, we need a grasping tool to help us to grip the small piece of lid sleeve. And then the bush component is then removed because it is not a TMPC and does not have any relative motion. Furthermore, it is made of the same material as the other part, so removing the part will not have an impact on the other part. The recommendation of improvement. As we can see in the table, the red circle indicate the area that have need to be improved to make design more efficiency. The right side of the table show the design that have been improved after according the data in the DFA table. The table at the right side is the before improvement. That is the area before combination part of cone and lead sleeve. And the right side is the table below show the combination of the part between lead sleeve and cone. And the point number 2 is for before improvement, there is the existing product of mechanical pencil, and after improvement, the bush is removed from the part of it.
Okay, I will continue for this discussion regarding improvement. Okay, for the first point is by combining the two components of the lead sleeve and cone, it has been possible to improve the performance of the item. Okay, the next point is in order to properly insert the lead sleeve, we need a grasping tool to assist us in holding the small piece of lead. The next point is because the material are the same, the manufacturing process is the same as well, allowing for cost saving in the manufacturing process. The next point is the bush component has been removed from the mechanical pencil part because it is not TFPC and does not have any relative motion. The next point is the removal of the bush component and the combination of the lead sleeve and cone part will lead to decrease in the design efficiency, assembly time, and assembly cost of the mechanical pencil. And then the last point is the difference between the existing cost and the cost of the improvement part can result in a cost saving of approximately RM 6 cents. Okay, we go for the drawing improvement of final product. As we can see in the drawing below, the lead sleeve are combined together with the cone, which the material of the lead sleeve is changed into plastic that the manufacturing process is a plastic injection molding. Okay, below. Okay, we go through for the DFA improvement. So this is the DFA table of improvement design. So as you can see, the quantity of the product, the part of the product is reduced for the 8 pieces, and then the TMPC amount is still 1 for the body part, and then we will find the data for manual handling time and insertion code, and then after that, finally we will get the total operation time and then the total of assembly cost. So the design efficiency calculation, the final result of the design efficiency calculation is 5%, and then for the final result of the assembly cost is RM 51 cents. Next. So for the comparison, as we can see in the table below, it has been mentioned as before in the improvement section, which is we can see the before and after improvement. So in the table in the right circle is indicate the part that is before improvement, and also in the right side shows that the part or the design after the improvement. Okay, next. We go for the conclusion and recommendation. The first one is conclusion, design for manufacturing manual assembly, which is the DFMA method, is quite effective for analyzing the design of a mechanical pencil. Then this strategy is also extremely beneficial for improving the design efficiency and operational cost of the product under analysis. Next, apart from that, a comparison of design efficiency and assembly cost before and after improvement demonstrates a significant improvement when this method is used. Next, this is because the completed product will have a higher level of efficiency, time, cost due to the reduced number of part and part count. And finally, by redesigning the mechanical pencil and lowering the number of components, the DFMA can significantly reduce the overall assembly cost. Okay, for the next conclusion and recommendation, then by reducing the part cost, it is possible to increase the product reliability, hence reducing the likelihood of product failure. And the next, additionally, it may be said the minimizing the number of part increase design efficiency, hence lowering assembly cost. Next, the part that have been evaluated that can be combined to form a single component is called endless sleeve. Next, the bill of material for the input design can be reduced from 10 components in the existing product to 8 components in the improved design by combining the cone and sleeve and eliminating the bush component due to no relative motion are involved. And the final point is the finding of digitally indicate the DFMA method is quite beneficial in